because it takes a long time for forest to grow. So what happens initially is the trees are planted and you get input growing, you get volume increasing at an increasing rate. Okay? Then it hits some maximum growth level in here, but volume still goes up, but it's growing more slowly. So it's increasing at a decreasing rate. So the rate is changing along the curve, but the volume is still increasing. At this point, you've reached full maturity, after which, so you've heard of old growth? This is old growth in here. And what happens to old growth? It dies and it falls over. And the volume of the forest actually goes back down. You can think of the same thing with agriculture, for example. If you're adding water, you get increasing growth at an increasing rate, then it increases at a decreasing rate, and then here you have flood and an actual decrease in the volume of output. So practically any example you can think of will follow this shape because you've got one input and because you're holding all other inputs constant. Okay? So there are what we're trying to do, the ultimate goal here, is to determine what is the sustainable harvest. To determine sustainable harvest or the time to harvest. Same thing. In forestry, we always want to know the rotation. You plant the trees, you grow them to a certain size, and the size will determine which market it goes into. If you get big fat trees, it goes into the log house market. If you get little skinny ones, it's posts and poles. Somewhere in the middle, you get 2x4s. So whatever you're producing is going to be determined by how much volume you have and the value of that volume. For now, we start with the production function. So what happens if I don't manage the land properly? If I don't fertilize, if I don't water, if I poison the soil, if I pollute in some way, I'm not going to get the volume of output that I expect. You say, well, okay, what if I do it this time and I harvest and then I sell the land? The land is not going to be as valuable either. So you have an economic incentive right from the get-go to take care of the physical resource. And that's how the physical resource, the sustainability of the physical resource, is tied to the sustainability of the economic resource. If you don't look after the capital, you're not going to have future revenues from it. Okay? So there's an incentive built in. Okay, so from here, we have a couple of important points. This would be considered the maximum growth rate. And it's growth rate. Okay? It's not maximum volume. You've got volume over here. So this is where the forest is growing as fast as possible, after which it's still growing, but it's not growing as quickly. So this is the maximum growth rate. This point, right at the top here, is maximum volume. There's another maximum point, and that is the maximum average volume. So if you took the total volume divided by the number of years, that's just like you would calculate a grade point average. You take your total grades in the classes divided by the number of classes. And that is somewhere in here. This is max average volume. Okay. Now, if you're talking about forestry, this is called periodic annual increment. If you're talking about fisheries, it's called maximum sustained yield. If you're talking about something else, it likely has a different name. But it always means the same thing. Maximum growth rate, maximum average, maximum total. And we use these points to determine the best place to harvest. Okay? So if you were to calculate these, the maximum growth rate is the maximum change in volume over the change in the input, in this case time. Okay, where that reaches a maximum, that's maximum growth rate. The maximum average volume, to calculate the volume, would be average is volume over time, or the input. Calculate the maximum volume, you just look at the maximum volume. Okay? So we have names for these things in forestry. So we have mean annual increment. It's known as MAI. And all you really have to remember is mean. The mean is the same as the average. Okay? So the MAI is calculated as volume over time. If you want to be general, it's quantity over input. We have the maximum growth rate is known as periodic or current annual increment. So it measures the growth at each point in time, from year to year. How much more did we get this year than last year? So we call that periodic, annual increment. PAI. So in this case, it's the change in quantity over the change in the input. So it's a margin. We're looking at just a small change from one point to another. In this case, it's the change in volume over the change in time. So we can actually get a production function where Q equals a function of A to the BYX P whatever, blah, blah, blah. Another way to look at this is geometrically. If I were to take a measure of volume, I'm saying that it's the volume, the total volume divided by the time. That's also like taking the measure of a slope of a line, from the origin to a particular point on the graph. So the first one is fairly low, the slope goes up and up and up and up to the point where it's just tangent. So the volume is, the average volume is at maximum. Any lines beyond that start to go down again. So you can see that the average increases up to this point and then it decreases. A measure of the periodic annual increment would be like taking a small point, here's the change in volume, and here's the change in input. So really what I'm doing is taking the slope of a line just tangent to the point all the way along the graph. Okay? So I'm just looking at what changes from year to year. Am I getting more growth or less? And this is important because let's say you're up here and the forest is, you're adding very little, but at this point, what you're getting is zero, right? If I measured at this point, here's the change in time, and what's the change in quantity? Nothing. So what I'm adding to the total forest volume is zero. So you get different information all the way along the curve. Okay, so we graph this next. Get rid of this thing. Do you have any questions? I don't know if I'm going too fast or too slow. Everything's fine? Okay, you've seen it before, everything's cool? Good. So you can put one graph directly on top of another, which is what I'm going to do here. We have our input. And we have volume as the output. And we have the production. total volume. I'm also going to, if you put the graph right below, input is going to be down here as well. We've got time. We're also going to have quantity on this one too. So what I want to do is transfer the periodic annual increment and the mean annual increment down here and make a decision. So I know that this is the maximum PAI, and I know that this is where PAI equals 0. So if I transfer them down here, I know that this is a maximum, and at this point, this is 0. Oops. So I also know that the PAI increases up to this point, and then it decreases. So I've got a curve that looks something like this. Okay. So this is the periodic annual increment. I know that max MAI is somewhere in here. And I also know at this point that the mean annual increment is equal to the periodic annual increment. So at this point, where MAI is maximized, it also equals PAI. The reason for that is because we're measuring the slope of a line tangent to the curve. So from the origin to this point, for the mean annual increment, volume divided by time. And for the periodic annual increment, we're also measuring a line just tangent to the curve. Of course, they're equal. It's the same tangential point. So at this point, they're equal. And I know that mean annual increment, or the average, increases to that point, and then it decreases. But it doesn't go negative. Because you still have, even though you've got falling volume, you still have a positive volume and time. So it goes up to some point, and then it starts going down again. So this is the mean annual increment. So at this point, where MAI equals PAI, we can say that, well, we can't say anything yet. Hang on. We'll just leave this. MAI equals PAI at a particular point. Okay, so with all this biological information, can we make a decision where to harvest? Let's say you go into the forestry business. Would you know where to harvest at this point? Think logically. What are you going to need? What kind of information are you going to need to harvest your crop? Whether it's
the volumes increase.
Okay, so you understand about the volume. The volume's growing, right? At some point it'll start decreasing. So you certainly want to harvest before you have old growth, right? Yeah. Can you make a decision about where to harvest?
MAI equals PAI.
That is where the Forest Service of the United States, that's where they harvest. And it's where the provincial forests, many of the provincial forests, decide what is biologically sustainable. This point is also where, if you harvest at this level, let's say this is, we'll say at this time, T star, so this is where the harvest equals the growth rate. So if you never harvest more trees than you're growing, are you going to have trees for the rest of time? Yeah, probably, right? Assuming that you're going to replant them and they keep growing and you've got forest renewal, everything should be fine. If you never harvest more than you grow, you will have the same stock of timber. Your timber stock won't go down. So we should be able to manage forests sustainably. Now, as people in business, Is this enough information for you to make a decision?